Okay, so tuloy natin ano. Last time na discuss natin yung T-beams. Nakaisang problem tayo yata ng T-beams and then today we are going to continue with some problems on T-beams and shear reinforcement and then if we have time, development length. Okay, so sort of review, no? We have to identify for the smallest value of B or the wide flange. B or the wide flange according to this condition. 1/4 of span, 16t plus b prime, and the center to center spacing. And then there's different condition as well kung nasa edge siya ng or nasa perimeter ng building. 1/12, b prime 60, b prime plus 60, and then 1/2 of the center to center spacing. Okay. To move. Okay. Ito. So, sa T-beam, just like double reinforced beam, hinahati lang yung compression block kasi you could not easily analyze the T-beams if you are going to take consideration into this whole block. Ano? So, separate yung compression block with the focus on the slab and then separate naman as C2 yung compression block doon sa part ng web. Okay, so ang concept niya is the same with that of the similar to that double reinforced beam na may dalawang forces doon sa taas. So that causes them to rotate for M1, M1 at saka M2. Yung M1 at saka yung M2. So dito mayroong M1 and then dito naman mayroong papunta pala dito. And then you have here also M2. Hint lang dito, yung reinforcement dito, A is 1, dito A is 2, and then you will come up a total for AS. Okay, so let's try this problem. Okay. So you have here a reinforced concrete T-beam has a slab thickness of 100 millimeter, which is supported by a 6.5 meter span length beams cast monolithically with slab. So obviously it's T-beam. Spacing of beam is 2.4 meter on centers, and the web width is 300 millimeters. So ang drawing natin, so we have here our T-beams. Okay. So according to the problem, this one is 100 millimeter thick. Okay, and then spacing of beam is 2.4 meter center to center, and the width of the web, this one is 300 millimeter. So obviously our reinforcement is coming here. Okay, what else? Effective depth is 485. So from here, going here is equal to 485, which is our D. Okay, the beam carries a live load of 163 and a dead load of 84. Okay, so you have your 163, that live load, and then dead load is 84. FC prime is given, Fy is also given. So if we're going to draw here the internal forces, so of course we do first. Okay. That is, if we assume that this is T-beam, it will come over here, okay? But let us check first, okay? Let's compute first. Which of the following gives the effective weight of flange? So, first, number one, okay. Effective weight of the flange. Condition. First condition, you have one fourth of span. Okay, one fourth of span. What is the span? Span is 6.5 or 6,500 millimeter. So that is 1625. 1625 millimeters. Okay. Number second condition, B prime plus 16T. B prime plus 16 thickness of the slab. B prime, which is the width of the web, equals to 300 plus 16. Thickness of the slab is 100 millimeters. Obviously, it's 16 plus 300. You got 1,900 millimeters. Okay. 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 Next. Next is the center to center spacing. As a problem is 2.4. 2.4 or 2,400 millimeter. Obviously here, pinakamalit is itong 1625. Okay. So use B equals to 1625 millimeters. Okay. Easy. First question. Okay, next question. Which of the following gives the area of the steel bars needed? Okay. So how we compute? How do we compute? Of course, we need to get for the area of the steel bar. You need to compute what is moment. Okay, here given dead load and live load, the combination, and then the steel ratio. Okay, but we have to check first if A is greater than 100. If A is greater than 100, in that case, we are going to consider T-beam. Okay, so let's see. So first, number two. Number two, we compute first MU para ma-compute yung total area. Because we need to check first if it's falls on the web. If it falls on the web, we are going to calculate as true T-beam. Otherwise, we'll just have the rectangular beam analysis. 1.4 dead load plus 1.7 live load. As I said in a previous session, may 2015 na 1.2 at saka 1.6 if I'm not mistaken. Pero the combination, the problem sa mga napagtanong-tanong ako, ang mga nag-take ng exam, kino-consider pa rin nila itong combination, just a sort of reminder. Anyway, kung gagamitin yung bagong code, bibigay naman nila yung combination. Okay, so let's continue. 1.4, according to the problem, dead load is 84. Okay, 84 kilonewton meter. And then you have 1.7 live load. Live load is 163. 163 kilonewton meter. Okay, so our MU is equal to, you can calculate, 394.7 kilonewton meter. Okay. So, out of this one, we can compute what would be the value of A. Okay. If we just try first, okay, that our beam is that okay, we can try first that our T beam, the analysis is just rectangular beam, which means that our A is in the kasi hindi man masyado malaki yung moment, okay? Let us assume that this one, okay, that the neutral axis falls here. Sa board exam, pagka nakapag-compute ka na ng mga problem na related, na-compute mo na itong specific na problem, alam mo na na nasa kwan talaga siya, na nasa flange. Okay? Pero pag di mo alam, you have to try. You have to check if you are going to treat it as T-beam. What I mean is, kung yung A mo is coming here, ano? Kung yung A mo is smaller than 100. Kasi ang thickness nito, this one is 100. If A is greater than 100, in other words, that we are going to analyze that as true T-beam. So therefore, you have here as your C, okay? And then you have here as your T. This one, this is 0.85 FC prime, okay? This is D minus A over 2. In other words, we can have here a moment, MU is equal to phi. We can use the compressive force, okay? C times D minus A over 2. Okay? So let us substitute. Alam naman natin na C is just the volume of the concrete compressive block. You have 0.85 FC prime, ito yan, times A, times B na na-compute natin earlier to be 1625 millimeters B. So then we can substitute here. We know that MU is 394.7. We can convert to Newton millimeter times 10 to the power of 6. Newton millimeter is equal to, reduction factor for flexure is 0.9. Okay. C is equal to 0.85. 0.85. FC prime is, how many FC prime? 20.7. Okay. A, we don't know. B is 1625. And then we have here again D minus A over 2. D is 485 given from the problem. 485 minus 0.5 of A or A over 2. Okay. So if we are going to solve this one, you're using your calculator, makakompute nyo na, no? That A is equal to 32.73. Calculate mo na lang, calculator. No? Which is less than 100 millimeter. In other words, therefore, we just treat this one, treat as rectangular beam. In other words, our analysis doesn't need to have the T-beam analysis. So in that case, madali na pag-compute. Because from here, we can sum of forces horizontal. Okay? You have summation forces horizontal equals to 0. You have here C is equal to T because we already have A. Therefore, this one is complete. You have A, you have B, and then T is equal to AS FY. The question is to compute for AS, and then we can compute AS now. So this is 0.85. FC prime is 20.7. A is computed to be 32.73. We don't need to write the unit. All our units are in Newton and millimeter. A, and then B is 1625 is equal to AS. FY is given to be 413.7. 413.7. In other words, you can calculate AS. AS is equal to 2,262 square millimeter. Third question is to compute for the number of bars. Number of 25 mm bars. Ay, ito madali na to. Once you have your AS, then you can compute the number of bars. So number 3, number of 25 mm diameter. Okay, so number of 25 is just equal to AS and then yung area ng isang 25. Okay, AS is equal to 2,262 square millimeter all over area of 1 bar 25 squared. In other words, you have 4.6 or let's say 25 pieces of 25 5 pieces. Okay. So you have 5 pieces of 25 diameter. Okay? Okay lang.
Okay lang po.
Madali lang naman. Ano? Sabi mo lang kung may tanong. Okay, let's
Okay
continue.
po, sir. Ano po?
Okay. Okay, anong next question natin? Ko. Okay, this one. Let's try this one. Pinagadaan ko pa naman yung mga classmates ninyo. May mga writing pad pa ako. Wala nang pumapasok. Itong
Nabawasan na sir yung ano.
Itong ginagamit kong Microsoft itong PDF annotator, pa to, license to. Kasi walang crack to. Tapos may ako na Wacom na writing pad para mas madali yung pag-calculate. Kasi pagka yung calculation na nakita niyo sa lang PowerPoint, meron din. Yung preparation masyado matagal, tapos kunti lang na ganda pa rin yung sinusulat kina-calculate.
Opo.
Dito si Sir Dennis.
Minadagdag po na isa.
Sir Dennis yan. Okay, so continue natin. Okay, so this one, you have a board exam type tendent na problem. Kaso 2006, di lang naman natin alam. Pag lumabas, at least yung nasa data bank. Ano? Kung mag-update man sila ng data bank, ito, andun pa rin to, may malaking chance ulit na lumalabas. Nagpa-part-time ako sa FEU ngayon. Ganun lahat ng exam, nasa data bank. Magagawa ko ng exam, papasok ko doon. So, malaki mga chance na lalabas talaga to. Ano? Parami yung mga questions doon sa question bank. So, pero malaki pa rin ang chance nito ng mga question. Kaya sinusolve ko na lang yung mga problem ko. Board exam type. Okay, so this is a reinforced concrete T-beam. Has an effective depth of 600 millimeter and is reinforced with 828 bars. The web width is 300 millimeter and has a flange thickness of 90 millimeter. The beam has a span of 5.8 and spacing of center to center equal to 1.5. Halos similar lang naman. No? So, medyo bilis na lang natin yung una. Number 1, ang choice lang nito is first, 1/4 ng span. 1/4 ng span is, ano yung span? 5.8 or 5,800. Pipili lang tayo ng mas maliit, pinakamaliit. So you have 1/450 millimeter. And then the other one is B prime plus 16T. Okay? So B prime natin, 300. 300 plus 16. Yung thickness ng slab is only 90. Parang hindi masyado realistic. Nasa margin na. No? 90 mm. Anyway, compute lang natin. Dapat at least 100 kasi 75 yung Okay. So this is 1740 Okay, and then the other one is the center to center spacing. This one is 1.5 or 1,500. So obvious na ito yung gagamitin natin na. Therefore, use B is equal to 1,450 millimeter. Number 2, which of the following compression block? Depth of the compression block. Okay, so parang similar to sa unang problem natin eh. Hindi mo na, actually hindi siya true T-beam. Okay? So, ibig sabihin, draw lang natin yung beam, ano? Ibig sabihin, we treat this one as rectangular beam. So, T-beam, okay? So, this is 90. This one is 300. Okay? So, if, so you have here, so, if within the slab, ganun pa rin, ano? C, T. Okay. So, this one has given yatang, what's this given? Given yung reinforcement, ano? Given yung reinforcement. So here, you have here this one. Okay, this is 828. Okay, 828 diameter. So if you have AS, actually this one is AS FY. This one is 0.85 FC prime. Tapos A, ito yung A dito. And then B is given. So ito lang ang unknown. Ito known. So we can compute A. Ma-identify natin kagad yung compressive block. Okay, so therefore C is equal to T. Okay, C is equal to T. So C is 0.85, FC prime is 21, A is unknown, B is 1,450. Okay, AS, what is AS? Pi over 4, 28, ilang peraso? 8. Okay, this is equal to 4926. 4926 square millimeter. So therefore, we can substitute here 4926 Fy is equal to 415. Okay, so we can have here A equals to 78.98. This one shows that this is lesser than 90. Kasi maliit masyado yung moment, ano? Siguro maliit siguro yung moment. Or kahit malaki yung moment, malaki naman yung beam. Okay? So, nagfo-fall siya yung kuwan. Tapos maraming bakal din. Kaya yung compressive block, hindi siya umabot dito sa kuwan, sa web. Pagka limited kasi yung section, aabot siya dito. Ano? Kasi yung resistance ng compression block, yung compression block lalaki kasi maliit yung section. Pero kapag malaki yung section, aabot lang siya dito. Ano? Sa flange lang. Yung iba nga, yun ang concept ng double reinforced beam. Pagka limited yung section ng beam, malaki yung moment, malaki yung load, yung resistance ng compression block, not enough. Kaya there is a need for an additional compression reinforcement. So in this case, hindi na siya kailangan ng umabot dito, no? Kasi malaki yung, enough yung section. So we have 17.98 as our compressive block depth. Number 3 is to compute for nominal moment capacity. So MN lang, ano? So walang reduction factor. So we can use T, okay? We can use T times D minus A over 2. Kasi given na naman, na-compute na natin yung A, okay? Yung T, andyan na, ASFY. So you have AS, okay? This T is equal to ASFY, okay? D minus A over 2. So we have AS equals to 4926. If Y is 415, D is 600. 600. A has been computed to be 78.98 divide 2. So therefore, we can compute here the nominal moment, which is equal to 1146. 1146 kilonewton meter. Actually, it's 1146 times 10 to the power of 6. Ano? Diretso na natin sa kilonewton meter. Okay? Activity tayo. Try nyo to. Board exam type to, 2013. Di ko lang alam parang hindi T-beam. Parang kwanto. Double reinforced beam. Na-discuss na naman natin to. Okay, paki-visit lang yung kwan. Yung try nyo lang. Paki-visit yung kwan natin. Yung classroom. Ito, activity 1. Try, mag-practice daw tayo pag-solve. Okay? Click nyo lang. Ayan naman. Wala na akong mga choices. Makikita nyo naman ang answer pagka nagsagot kayo. Okay. Huwag nyo nang ilagay yung mga unit na millimeter. Okay? Mga 10 minutes siguro. Pwede na. Okay? Start. Okay, are you done? Check ko lang. Okay. Kuha mo ang isa. Si Roberto. Nagdoble itong isa. Okay. Anyway. Nakuha mo naman yung isa. Okay, so tuloy natin. Okay na ba?
Okay po.
Okay. Okay, so this one. Okay. Computer natin. Kung natin yung question. Okay, so this is a concrete beam, 350 by 250 by 400 deep, is simply supported on a span of 5 meters. The beam is reinforced with 428 diameter bars in tension and 228 reinforced in compression. Okay. So dito, so rectangular beam pala to, hindi T-beams. T-beams. This one is 428. And then this one is 228. So, this is AS. Alam natin na AS is equal to, ayan, given na 4 pieces, okay, of pi over 4, 28 squared. Okay. So, this is equal to 428 to 463. Tama? 2463 square millimeter. Okay. Then, ito naman sa taas, ito is AS prime. Okay? Prime or A is 2. Dalawang 28. Pi over 4 times 28 squared. So, obviously, that's just 1/2 of 2460 is 1231.5. 1231.5. Okay, so the first question says, calculate the depth of the rectangular stress block based on a uniform compressive stress of 0.85 C prime and maximum concrete strain 0.003. For simplification, assume that both tension and compression still yields. Neglect concrete area displaced by steel. So the question is to compute for A. Okay. Okay. So from here, gagawin natin ulit dito. So we have here, una dito, so you have here for T1, and we come here first with C1. Ito na yung A. Ito yung A na tinatanong. Okay? If we know T1, then we can compute C1, which is just equal to 0.85 FC prime A times B. So, A lang naman tinatanong. So, T1 is equal to AS1, okay, FY. What is AS1? AS1 is equal to AS, again, para mas madali. You have AS, I should say, or the total reinforcement, AS, yung bottom actually yan, is just equal to AS1 plus AS prime or AS2. Ito alam natin na AS is equal to 2463. 2463. AS1 is, I don't know, but AS prime, we know that it's 1231.5. In other words, AS1 is also equal to 1231.5. Okay? So we can use now this relationship that C1 is equal to T1. Okay? Pagka nag-sum up tayo ng forces horizontal, considering this, considering these forces lang, itong sa may moment 1 lang. So C1 is equal to 0.85 FC prime A times B is equal to AS1 times FY. We are looking after for A, so we have 0.85. What is FC prime? 20.7. A is to be computed. B is given to be 350. Okay. AS1 is also computed as 1231.5. FY is 415. So in short, we can calculate A equals to 82.99. 99 millimeter, or we can say that this is 83 millimeters. Okay, what's the That's the next question. Determine the design bending strength mu with capacity reduction factor of 0.9. Okay. So you have here number 2, tinatanong yung mu. Mu is just equal to phi mn or m1 plus m2. Okay. Ano yung m1? We can use T1 na nakalculate na natin kanina. T1, okay, ano? Nakalculate na natin, no? T1, ito, this is D minus A over 2. Okay? So, you have your M1 is equal to T1 D minus A over 2. Ano yung T1? AS1, FY, anong D? 330, given naman sa problem, minus A over 2, which is computed just a while ago. Oh, A is 1, is 1 to 3, 1.5. FY is 415. And then you have 330 minus A is 83 over 2. So in other words, you can compute M1 equals to 147.45. 147.45 times 10 to the power of 6 Newton millimeter. Okay. Now, how about M2? Okay. Kita sa, okay. Here, okay. For the reinforcement here, ano, na may distance dito na, ang distance niya is 70. Ano? 70. Concrete, ano, not concrete cover. Distance from the the topmost fiber to the center of the reinforcement. So, andyan siya, no? So, this one is C2. And then you have here, ito naman yung T2. Okay? Then, this distance happen to be D minus D prime. Okay, so we can have here T2 times D minus D prime. Alam na natin yung T2, yung AS2. Okay, so you have here T2 D minus D prime. T2 is equal to AS2, okay, AS2 or AS prime, okay? Pwede natin ilagay AS prime because we are constantly using AS prime. Fy, and then you have D minus D prime. Okay? What is A is prime? It's just the same with A is 1. 1, 2, 3, 1.5. Okay? Anong Fy is 415? You have 415. D is equal to 330 minus 70. So therefore, you have M2 is equal to 132.9. 132.9 times 10 to the power of 6 Newton millimeter. So therefore, we can compute mu is equal to reduction factor na 0.9. M1 is equal to 147.45 kilonewton meter na lang, ano? Plus 132.9. So we have mu 252.3. 252.3 kilonewton meter. What's the last question? Okay, the last question, if the beam were reinforced, okay. Okay. If the beam were reinforced such that the nominal bending, okay, the nominal bending strength at factored loads is 400 kilonewton meter. So ito kahit walang hindi mo masagot yung previous problem, isolated na question to. So in other words, given yung kung given daw is 400 kilonewton meter factored load, nominal pala. Nominal pa lang. So MN siya, no? The beam were enforced such that the nominal bending strength at factored load. No? Factored na siya pero nominal pa lang siya. Such that the nominal bending strength at factored loads is 400 kilonewton. What is the safe concentrated live load? Okay. At midspan that the beam in additional to a total load of 20 kilonewton meter. In other words, you have here a beam. Merong beam ka dito. Simply supported beam. You have the support. The span is it's given to be 20, given na sa una, no? Una pa lang. 20 ba? What's the span? 5. 5 meters ba yan? 5 meter, given sa problem. So, using 5 meter span, meron daw uniform load na dead load. Ang uniform load na dead load is 20 kilonewton meter. Okay. Now, the question is to compute for the concentrated live load. Concentrated live load. What is the safe concentrated live load at midspan that the beam in addition to a total load of 20 kilonewton meter? Okay. So MU here, actually MU is just equal to reduction factor na MN is just equal to 1.4 moment dead load and then 1.7 moment live load. Yung 1.4 dead load natin dito, due to this uniform load na W dead load L squared over 8. Yung live load naman 1.7 pagka concentrated nasa midspan is just P live load L over 4. Okay, so here we can substitute VMN 0.9 times 400 times 10 to the power of 6 na lang pag Newton meter tayo. O pwede 400 kilonewton meter na lang. Okay. It should be that if you have 400 kilonewton meter, the rest of the units should also be in kilonewton and meter. So you have 400 kilonewton meter. You have 1.4. W dead load is 20 kilonewton meter. This is squared, okay? Span is 5 meters squared. Okay. And then you have your 1.7 factor for live load. PL over 4. P live load, L is 5 meters, and then you have 4. So here, ito na lang ang we can calculate here. You have 1 to 8.2. Kung magka-calculator kayo, that becomes 1 to 8.2 kilonewton. So this is the additional load na tinatanong. Kung meron na daw existing na uniform load na 20 kilonewton meter at saka yung nominal bending strength factored na 400. Pagka nominal siya, multiply lang ng 0.9, then you have it to be MU. Magiging MU siya na magiging equal dito. Okay. Okay. Any question? Okay lang?
Okay lang po.
Okay, so let's continue. So nakuha mo naman yung sino pa ba nagsagot? Sir Dennis, nagsagot ka ba?
Wala pa, sir. Wala pa.
Okay lang. Okay, try mo na lang some other time pag may time ka. Okay, so web reinforcement tayo. Okay? Web reinforcement, or we call it as stirrups, o shear, web reinforcement or shear force. Okay, so ito lang ang concept naman ng one. This is the concept of shear reinforcement. Okay? Kaya nga pag tayo makaka-relate tayo kasi nakikita natin sa actual na siksik yung reinforcement dito. Kasi the critical part for the shear reinforcement is at the distance from the face of the column. So, ibig sabihin, mula sa face ng column or sa support, yung D na yan, dyan yung maximum na critical section for web reinforcement or shear reinforcement. In fact, yung calculation natin at the distance from the face of the from the support, at the distance from the support is your maximum shear or the critical section for your shear force. Kaya tawag dyan is a factor shear force at critical section the distance from the support of the beam. Hindi siya yung reaction, babawasan mo pa ng the distance. Dali lang, pag-calculate kasi dito, yung shear diagram niyan, ito, reaction yan. Pagka binawas mo to, area lang yan, Itong height na to is W. Ito naman na distance is D. Pagka minultiply mo W at saka D, yun na yung equivalent na shear na load na pababa. So kung mayroong R kang pataas, ito yung pagkat mo section, ito ko na lang drawing. Okay. Andito yung R, nag-cut ka ng section dito. Andito yung WU times D. Andito yung VU na factored shear force na considered at the distance from the support. Kaya VU is just equal to, kung reaction to, R minus WU D. It's coming from this, coming from here. So yung VU na yan, this VU is the summation of the factored shear capacity of the stirrups at saka shear capacity ng concrete. Pagka masyadong maliit na to, yung VS, ibig sabihin, hindi na nangangailangan ng stirrups. Kaya nga pagdating dito, masyado wala na siya, maliit na. So, di na daw kailangan ng stirrups dito, itong VC over 2. Pero syempre sa actual, hindi naman, as a matter of fact, sa code, may nire-require siya na D over 2, doon sa na. Yung tinatawag na non-requirement na shear reinforcement, at least D over 2. So, kaya kadalasan, pag may 500 ka lang ba depth, safe na dito at 250 spacing. Pero dito, nag-upisa tayo ng 50, 100, kadalasan gano'n. Pero kinakalculate natin, common na kasi yung spacing, kasi safe na siya. Kasi minsan nagkakalculate tayo 75, 100. So pag ginamit 50, as may yung ECI na, hindi 318, 315 yata yun. May detailed kuan. Yung detailing ng reinforcement, andun yung sinasabi yung mga detail na reinforcement. Pero dito naggagaling yung calculation na yun. So for the purpose of our discussion, ito yung VU is just equal to VS plus VC. Ang VS yung shear na nadadala the shear that is being provided by reinforcement, at saka yung VC naman provided by concrete. Kaya yan, Okay? So yung VS makakalculate natin. Ibig sabihin, yung spacing yung required na spacing ng stirrups pagka nag-calculate tayo. Ito VC, given naman yan, formula. 1 over 6 FC prime, square root of FC prime B, D. Okay? So, for the purpose of discussion, dito nang galing, pagka nag-cut ka nito, kinat mo ito, tingnan mo sa taas, ang makikita mong bakal, dalawa, kinat mo ganun. Ito yung mga stirrups, andito yung main reinforcement. Andito yung main reinforcement, main bar. Ito yung stirrups pag kinakat. Ito may piniprovide siya na shear reinforcement. Kasi nga dito yung shear crack, kailangan meron dito para hindi siya maghiwalay. So, itong shear reinforcement na yan, okay, wait lang, charge ko lang. Okay, let's continue. So yung shear reinforcement na yan, parang kwan lang din yan, ang formula lang naman lagi niya, yung area ng bar at saka yung design strength ng reinforcement. Kaya nga, alala niyo sa singly reinforced beam, meron tayong ganito. Ito yung T. Ang formula niya is just area of the reinforcement at saka yung yield strength ng bakal. So similarly here, ito AV, area ng reinforcement, saka FY din. Tapos i-multiply mo ng dami nito. 1, 2, halimbawa, for this D distance, you have 1, 2, 3, 4, 5. Halimbawa, or N. AV, FY, saka yung number ng bakal. For this particular na D distance, makakompute lang naman natin. Alam na natin yan na D over S. Yung D, distance, multiply mo ng spacing, meron ka ng number ng bakal. Kaya pag sinubstitute natin yan dyan, makakapag-come up tayo, we can come up with this formula, VS, EV, if Y, instead of N, D over S. And then we cross-multiply, makompute na natin yung spacing. Diyan lang yan ang galing. Madaling derivation lang, spacing. Okay? So, we need to compute VS. VS, galing na to doon sa sinabi ko na kanina na derivation natin. VC given, kasi derivation natin, alam natin na yung critical na shear force is just yung VS at saka yung, ibig sabihin, yung pino-provide na shear reinforcement ng stirrups or yung bakal, at saka this one is the shear force provided by concrete. Pareho sila shear, para ma-meet yung VU. Otherwise, if it will not meet, halimbawa ito malaki, if this one is bigger, VU is bigger than the shear provided by both reinforcement or stirrups and then concrete, magfi-fail siya sa shear. May kakaroon ng shear failure. Shear failure will occur in the shear. So from here, makompute natin ang VS. Ano yung EV? 157 kasi dalawang 10 mm. 10 mm naman ang ginagamit lagi natin na stirrups. Okay? Wala nang iba. Walang 12. Mahirapan tayo sa pag-bend. Minimum siya. Okay? So, what else? So, some conditions that we have to check. When VU is less than VC over 2, so ibig sabihin, no need for stirrups na. Yun na yung pinakita ko dito. Pagka ito daw na VU, if this VU is already smaller than this, ibig sabihin, andito pa siya. Dapat nandito na. So, no need na for reinforcement. Ito yung pinaka-check niya. Kasi nga, from the graph itself, di na kailangan ng VS. So, if VU is less than VC, no need for shear reinforcement. Theoretically. Pero sa actual, maglalagay ka na yan. At least di over 2. Very na yan. Malaki na yung spacing. Kasi you cannot hold into stable naman yung main reinforcement. Wala ka naman stirrups. Isa din yung practical reason. But when VU is greater than VC, that's the time na kailangan mo ng stirrups. Ibig sabihin, yung VU mo, nakaganon, andito yung VU, andito yung VC, meron dito kinakailangan. There's a need for VS. Pagka masyado yung VC, if VC reaches up to here, wala ng VC, yun yung equal or less than, dito less than sinasabi. Pagka less than, wala na talagang stirrups. So madali siya maalala. Your VU should be greater than VC so that there will be VS. Meaning if there is VS, there is stirrups that we can use this one. Now, if your VS is less than 1/3 of C from BWD, okay, pagka malit siya doon, ang spacing mo is ito. Okay? Mas malaki yung spacing kasi mas malit pa siya sa 1/3 eh. VC lang ang requirement eh. Pagka mas malaki, ito naman yung D over 4, mas malaki-laki. Malit yung spacing, mas much stronger is the reinforcement to be provided against shear. Desirable spacing of stirrups is 100. Desirable. Ibig sabihin, safe na safe ka na yan. Pero kung sariling bahay nyo, mag-compute kayo kasi para hindi magastos sa reinforcement. Safe pang under-reinforced kumpara sa over-reinforced. Okay, so let's try our problem. Okay, saan problem? Okay. Okay, this is a simply supported, check mo kung naka-record to. Okay. A simply supported rectangular beam, 400 millimeter in width. Effective depth is 550. The factored load is 116 kilonewton meter on a 6-meter span. It is reinforced with 6,360 millimeters squared for tense tension reinforcement, which continues uninterrupted into the supports. Compute the design shear force, okay, which results from the application of the factored loads. So shear force, ano yun? VU. Ano daw yung VU? Alam naman natin, ano? Pagka kahit hindi na ilagay natin yung graph, ang formula is reaction. Ano? Ganyan. Or, pag ilagay ko yung graph, o yung shear diagram, ito yung, okay, the load is equal to 116 kilonewton meter. Span is equal to 6 meter. So, ang reaction dito, madali lang. Okay, 116 times 6 over 2. Okay, 116 times 6 over 2 is equal to, calculator. Okay. $348. If this is 348, this is also 348. Okay. Ang hinahanap natin na shear force, ano, pag i-draw natin yung shear diagram nito, obviously, ano, ganito. Kalate lang siya. So, we're looking for our shear force at D distance, okay? This is D distance from the face local. This is VU, okay? If we get this section, ito yan, ano? Ano yung VU na yan? So, ito yan, ano? R. So, VU R is equal to 348 kilonewton minus WU is 116 kilonewton meter. Anong D? Effective depth of 550 or 0.55 meter para consistent tayo sa unit. So you have minus 284.2. 284.2 kilonewton. Okay? Number 2. Compute the shear capacity of the concrete beam. What is the shear capacity of the concrete beam? Ano yan? VC. Ano? 1/6 square root of FC prime BD. Dali lang, ano? 1/6 square root of FC prime, 20.7. B is 400. 73 pala. 400. Ang square root lang ang FC prime, okay? And then D is 550. So you have 166.94. 94 kilonewton. Okay? What point is the web reinforcement no longer required measured from the supports? Asan yung what point? Ito yan eh. Mula dito. Ano yung distance na yan? This one is, ito yung VC over 2. Ano? We have this one, okay, which is 348. Ano daw yung point na, or distance, ano, na hindi na nangailangan ng okay, hindi na nangailangan ng stirrups. No longer required measure. At what point is the web reinforcement no longer required? So, yung hindi na kailangan, ano. Our control is VC over 2. Ano sabi natin kanina? Wala nang VS dyan. Okay, so what is VC over 2? or phi VC over 2. Phi VC over 2. Phi is 0.85. No? 0.85. Pagka flexure, 0.9. Sa column is 0.75. Okay. VC is already computed 166.94 over 2, 70.95 kilonewton. Okay, shear. So from this, we can have here this big triangle, a ratio proportion. Okay, is similar to this small triangle. So you have here 348 is to ano to? If that is 6 meters, so nasa gitna is 3 meters. Okay? Kasi kuwan siya. Symmetrical, ano? Uniform load. Ang drawing lang natin ang hindi symmetrical. 348 is to 3. And then that phi VC over 2, which is 70.95 is 2x. So we can compute the value of x. X is 0.61. So, meaning from the support, okay? From the support, or we can have this from here going to here. Sabihin na natin S. This is the distance na, okay? At what point is the wave reinforcement no longer required? Measure from the support. So, the measurement coming from the support, na wala nang, na it would start of having no reinforcement is equal to 3 minus 0.61. That is 2.39. In other words, at distance 2.39 from the support, yun na yung di na kailangan ng stirrups. So, mula dito, from here, going here, may stirrups pa siya. From here, going there, at the same din distance na S din, kasi symmetrical naman siya. Ito, kahit wala ng stirrups. Ano? So, pag mag-design kayo, pwede na, huwag nyo nang lagyan dito. Actually, lalagay pa tayo yung mga minimum requirement. Okay? But theoretically, di na kailangan siya ng stirrups. Starting that, so 239 dito sa left, 239 din sa kabila. Okay? Question? Okay lang. Okay, let's continue. Hindi ko nakita yung kanya, no? Magkuhan lang kayo kung may question. Tawag nito. Open nyo lang yung okay. Akala ko may na. Si Robin pala nadagdag. Okay. Okay, how about this one? This is a reinforced concrete beam, the board exam type to year 2000. Having a span of 4.3 meter, carries a uniform dead load of 60 kilonewton meter and live load of 90 kilonewton meter. The beam has a width of 380 and an effective depth of 570. FC prime is 21. Reduction factor for shear is 0.85. VC is given. So ito ganito talaga yung may exam, ano? Binibigay naman yung mga formula. So first question. Which of the following give the uniform load? Ito. Parang ko na to. Bonus, ano? Giveaway. Number 1. What is the ultimate uniform load? WU. So as I said earlier, pagka hindi nilagay kung anong factor, gamit muna tayo ng 1.4 dead load. Okay. Plus 1.7 live load. So you have your 1.4 dead load, which is dead load is 60. Then you have 1.7 live load is 90. Okay? So WU is 237 kilonewton per meter. Which of the following? Okay, factor shear force naman. VU. Kahit hindi na natin ilagay yung shear diagram, alam natin na it's equal to R WU times D. Ano? Ano yung R? Since simply supported naman ito, you just have the total weight na 237, okay, kilonewton meter. Multiply natin sa span. Anong span niya? 4.3 meters. Hinati mo kasi you have R1 and then R2. Then you have the reaction which is the same for both ends, ano? Equals to 509.55. 509.55 kilonewton. So therefore, we can compute her VU. Okay? 509.55 WU na 237 times effective depth na 0.570. Okay? So you have shear force, critical shear force or factored shear force is equal to 374.46. 374.46 kilonewton. Third question, which of the following give the nominal shear strength provided by shear reinforcement? So ang tinatanong nito dito is VS. Okay? 3 is, what is VS? Okay, madali siya ma-memorize. Alam natin, di ba? VU, ginaganon lang natin. Okay? VS at saka VC. Okay? So therefore, we can have here VS is just equal to VU over phi minus VC. Para mas madali mo ma-recall kasi sinasabi lagi natin na this critical shear force is the summation of the shear capacity provided by reinforcement and then the shear capacity provided by the concrete. Okay? So, let us compute what is VC. Is just equal to 1/6 square root of FC prime BD. Okay? So, you have here 1/6 FC prime is 21. B is 380. D is 570. So, you have here 165.43. 165.43 kilonewton. Okay, yung VC. May VC na tayo. Then we have VS kasi VU is 374.46 divided by 0.85 minus 165.43. Therefore, we have shear reinforcement capacity for steel equal to 275 kilonewton. Okay? Any question? Okay lang.
Okay pa po.
Okay. Okay, this one. Ito. So we have here given lahat mas madali siya basahin. First question. Okay, a reinforced concrete beam has the following properties. Beam width is 320, effective depth is 640, FC prime is 25, FY is 400, FVU is already given. Factored shear force at critical section, okay? So in other words, this is VU. Which of the following gives the shear capacity of the concrete? Okay, number one, bonus, Kasi ganun lang. 1/6 square root of FC prime BD. 1/6 FC prime is 25. B is 320. D is 640. So you have VC is equal to 170,666. 170,666.67 Newton. Number 2, what is the shear capacity of stirrup? So VS naman tayo. VS is just equal to VU. Na-derive na natin kanina, no? Minus VC. VU is given to be 200,000 Newton over 0.85 minus 170,666.67. Therefore, we can compute VS. 64627. 64627 Newton or 64.63 kilonewton. Okay. Now, the spacing of the stirrups. Number 3. S. Ano yung formula natin? AV FY times D over VS. AV. Ano? AV, yung dalawang section lang ng stirrups na 10 mm squared, multiply natin sa 2, you will have 157. Wala naman siguro stirrups na isang side lang. Okay? So you have here AV 157, FY is 400, D is 640, and then you have VS is 64627. Ayan. So you have 622. Masyadong malaki. So maximum spacing. Ano to? D over 2 or D over 4? Dapat i-compare yung one. Check ko dito sa kuha natin. Okay. Paano mo, when it is D over 2, when VS is less than 1/3 FC prime BWD. So let's compute first here. Okay. 1/3 of FC prime BD. Actually, this is just 1/2 of, okay, 1/2 of VC. Okay, VC is 1/6. I don't know. How about let's check. 1/6 times 2 pala para maging 1/3. 170,666.67. This is 341. 341.3 kilonewton. Anong sinasabi? When VS is less than this one, so ito, mas malaki ito sa VS. Okay? So, it should be maximum S is equal to D over 2. Okay. Ano yung D natin? D is 640. Therefore, use spacing D over 2. Ano? D over 2 is 640 over 2, which is 320 millimeter. Masyadong malaki. Hindi siya masyadong realistic. Anyway, for the sake of calculation, yun ang tama. Ano? Although yung na-calculate nyo 622, hindi yun ang gagamitin. Dapat 320 because according to the condition na yung VS, when VS is less than this one, you're going to use the maximum 320. But if VS is greater than this one, maximum should be D over 4. So, dapat mga kung pa to, 160 lang. Okay? So, let's continue. Not unless may tanong. Okay lang. Wala naman, oh. Dali lang. Okay. Ito. Ito. Board exam type. Sub na lang natin to. So this is CE Board 2014. Check lang. Okay. So you have here the figure shows, you have here a floor plan, okay, which is designed to carry a live load of 4.8. So live load is 4.8. Then you have 4.9 is your dead load. It includes weight of slab, beam, ceiling, partition, floor plan, everything. The slab thickness is 100 millimeter. The beams have a width of 250 and there's a depth of 350 millimeter below the slab. So excluding na yan sa 100 millimeter, ano? So ibig sabihin, beam nito, ganyan. Okay. Ito yung 100 na thickness ng slab. Ito naman yung beam na below daw the kwan. Ano? Na 350 and then you have here 250. Okay. The girder has a width of 350 millimeter and a depth of 400. Saan yung girder? Ito girder, ano? Ayun yun, nakasama. Girder, ito naman beam. Ibig sabihin, this beam is being carried by this girder A, B, C. Now, the 70 millimeter is the cover from center of steel. So, from the extreme fiber cover of the concrete to the center of the reinforcement is 70. Hindi siya clear cover. Assume the beam to be simply supported. Determine the critical factored shear force at the section for beam BE. So this one is simply supported. Ano? Simply supported siya. So anong i-carry nito? You're going to carry, actually may sa design ng slab, pag ganun tayo, no? Ganon. Okay? Pero in this occasion, pag magano, parang tinatawag nila yan na critical kuhan. Conservative. No? So ihati mo lang, ano? Hati mo lang. Ihati mo lang mula dito, ano? Ito yung magiging tributary area. Hati lang, you're going to carry half of it, ano? And transfer to the beam. Hindi na yung 45 degrees. Okay? Okay, so what will be our W? So if we're going to consider BE, ito yung B, ito yung E. Okay. Ito yung support natin. Ayun. Andito yung load natin. Ito dito ang support ito yung girder. Nakapatong siya sa girder. What will be our WU? Ito yan, ano? W natin dito, yung dead load nito at saka yung live load nito. So, dead load. What is WU? Okay. 1.4 dead load plus 1.7 live load. Ano yung 1.4? Ano yung dead load? Dead load is 4.9 kilopascal. 4.9 kilopascal kilonewton square meter. Okay. Okay. Multiply by, para maging uniform siya, ano, with this span na 6 meter, multiply mo siya dito. Ano? Ito yung tributary width. Kung 2.8 yan, 2.8 din dito, half of it is 2.8 pa rin. Okay? 1.4 dito, here is 1.4, also 1.4 here, kasi half nito, you have 2.8. So multiply natin ng 2.8. Okay? Plus 1.7, yung live load mo naman. Live load is 4.8. 4.8 pa din. Kilonewton square meter. Multiply pa din ng 2.8. Yung pa din yung tributary width. So therefore, WU is 42.056. 42.056 kilonewton meter. So this is now 42.056 kilonewton meter. Now what's the question? First question. Determine the critical factor shear force. So what is VU? Ano? VU lang tinatanong. What is VU? Is just equal to R minus WU times D. Or R is just equal to itong WU na 42.056 kilonewton meter, multiply mo sa 6 meters, total load na siya. Divide mo ng to, reaction na siya. And then you have again 42.056 multiplied by the effective depth. Anong effective depth? Effective depth. This is 350. Ano? Okay. Sabi dito na mayroon siyang cover na 70. Okay? This is 70. Effective depth will be from here. Ano? If this is 350, okay, the total is 450. Less 70, that becomes 380. Okay? So multiply here by 0.38 is your effective depth. Okay? So what's your VU now? Okay? VU is 102.83. 102.83 kilonewton. This is the first question. Second question, determine the spacing of the two legs of T10 mm. Ano? So, yun na yung VS, yung S. We are going to compute VS and then we also need to compute. Okay. Next. Number 2. What is spacing? Spacing is, familiar niya? AV, FY, dVS. Okay. VS is equal to VU over phi minus VC. Okay, what is VC? It's just equal to 1/6 square root of FC prime BD. Okay. 1/6. Ano yung FC prime? 20.5. 20.5. B is 250. D is na-compute na natin kanina, 380. So you have VC is equal to 72,037 Newton. VU, meron na tayo, so we can compute VS. VU na-compute natin kanina, which is 102,830. 102,830 30 divided by 0.85 minus VC na 72,037 Newton. So therefore, we can compute VS. 48,939. 39 ano to, Newton. Okay. Oh, so we have VS, we have AV. Alam naman ito na AV is 157, ano? AV is pi over 4, 10 squared times 2 is equal to 157. Actually, kahit di na kayo mag-compute, automatic na yun, 157. Okay? S. Substitute. AV is 157. FY is, ano yung FY? 275. D is 380. Take note ha, Newton millimeter squared ang mga unit natin dito. VS is 48939. So S is equal to 335. Okay. Number 3. Just check, ano? Check nyo na lang kung yung VS is less than 1/3 square root of C prime BD. Pagka less than, D over 2. Pagka greater than, D over 4. Pero dito sa kuhaan ko wala na, ano? Pero check nyo na lang din. Number 3. Question for number 3. Ito pala, yung palang question natin. Maximum spacing of stirrups. Third question is, using LCP, determine the maximum spacing of stirrups. Okay, so first, when VS is less than 1/3 square root of FC prime BD, ano to? 1/3 FC prime is 20.5. You have 250, and then you have 380. What is this? Calculate. 7. 144,075. 144,075. Yung VS natin is 48. 48,939. Okay? So, less than talaga. Okay? Pagka less than, we're going to use S is equal to D over 2. Pero kung greater than, if greater than, D over 4 ang gagamitin natin. So in this case, spacing is just D is 380 over 2. Okay, that makes what? 190 millimeter. Okay. Any question?
Okay lang po.
O, sige, hanggang dito na lang muna tayo. Ano? Medyo nakadalawan tayong topic. So next time, continue na lang natin.
Sige po.
Okay?
Yes, sir. Thank you, sir.
Kuha nyo na lang sa classroom, i-share ko tong, ewan ko kung nag-solve kayo, pero i-share ko tong na yung calculation ko na, naka-PDF naman yan. Okay? Naka-PDF, pwede nyo gamitin. And then yung link ng video. Okay? So, see you next time. Thank you.
Salamat po.
Thank you.
Okay.